Welcome to solverfy.
Okay, this problem is asking us to identify the reagents when given starter materials and their corresponding products. So here we have a cyclohexane with an alkene attached to it and a methyl group attached to that. And here is my product, where we have an alcohol. So what is the similarity between my product and my starter material? In my product, we have an alcohol attached to this carbon. In my starter material, we have this carbon. Those are the same carbons. So we have to identify, how do we put an alcohol onto that particular carbon? Well, this particular carbon is part of an alkene. That alkene is tri-substituted, meaning that has 1, 2, 3 things attached to it. And the hydrogen attached to this is not part of that substituted nature of the alkene. So on this carbon, we have the 1 thing attached to it, whereas this carbon, we have the 1, 2 things attached to it. So this alkene, this side of the alkene, is less substituted than the other side. So how do we put an alcohol onto the less substituted side of an alkene? The answer is hydroboration. So using the reagents BH3, THF, and hydrogen peroxide, sodium hydroxide, and a water solvent will facilitate that reaction. It'll add an alcohol onto the less substituted side of an alkene. Okay, next up, we have my starter material, which is the alcohol, and we are converting it into this product, where we have a bromine in place of the alcohol. So, how do we facilitate this reaction? Our initial response might be that it is HBr. Well, HBr usually only catalyzes the reaction if the alcohol is attached to a tertiary carbon. In this case, this carbon is attached to 2 other carbons, meaning it is a secondary carbon. So secondary alcohol. If it is a secondary alcohol, that means that it is prone to rearrangement if we were to use HBr. So we must use a more mild reagent, such as PBr3. PBr3 will facilitate the reaction by creating a mild condition where rearrangement does not occur, and it will replace the alcohol with a bromine. Okay, next up, we have this starting material, and we're given this product. Where we have a methyl group. I'll just write CH3. Okay, so how do we replace a bromine with a CH3? The answer is there is no immediate one-step mechanism. So we have to improvise. And the way we do that is we have a bromine and we're adding a carbon. Adding carbons, that corresponds to Grignards. That's what we've learned. By using a Grignard reagent, we know that we're going to add a carbon somewhere. So how do we create a Grignard from a carbon compound with a bromine? The answer is Mg. So step 1 would be Mg. Mg will create this product, or this intermediate, cyclohexane with MgBr. Okay, so I just created a Grignard, and now how do I create a methyl group to be in place of that MgBr? The answer is I need to have an electrophile. This right here is my nucleophile. I need to attack an electrophile that will facilitate the reaction of a methyl group being in place of that MgBr. So here is my electrophile, CH3I. My carbon nucleophile right here will attack the carbon and replace that iodide. The iodide will leave as a leaving group. So step 2 is CH3I.